So welcome to today's lesson. My name is Molim Samnyamo. Subscribe to the channel and also hit the notification button so that you don't miss when new videos are uploaded. Share also so that together we build an ocean of chemistry. So in our today's lesson we shall be looking at the mole, and more specifically we shall be looking at the relative atomic mass, the moles and the molar mass. The reason we are doing this, it's to clear the confusion between the relative molecular mass, the moles and the molar mass. To begin with, the mass of hydrogen, for example, is this gigantic, not actually gigantic, but a very minute number, which is 0.00000, very tiresome, 1674. But then the business of pronouncing this word has been made easy by mathematics. That is by writing the number in standard form, which is 1.674 times 10 to power negative 24 grams. That's a very minute weight or mass, sorry. So in chemistry, working with these figures would be very tiresome. Imagine feeding this number in a calculator. So instead of using these units, scientists devised a way to simplify the calculations by inventing the relative atomic mass. How it works, we look at this analogy here, whereby we have one big mass that is balanced by 5 smaller masses. Assuming that these 5 masses have the same mass, if the 5 small balls or masses balance one big ball, then the mass of the big ball relative to that of smaller mass is 5. That is, the relative mass of this bigger mass is actually 5. In this case, the small balls are taken to be the reference point. The same way in chemistry, since in 1961, the reference atom to measure the masses of other atoms is taken to be carbon-12. Carbon-12 is usually assigned the relative or the is usually assigned atomic 12 atomic mass units. That is to mean that its mass, which is given in atomic mass units, is taken to be 12. So all the other masses are usually measured relative to it. And that is now what brings about the relative atomic mass. Okay? The following formula is used in determining the relative atomic masses. And relative in this case, it is with respect to the mass of carbon. So every time you hear of the relative atomic mass of a given atom, that particular mass was achieved by getting the average mass of one atom of an element over 1 over 12, or 12 mass of one carbon-12 atom. For our level, we work with already pre-calculated relative atomic masses, which are given as follows. For example, these are just selected as example. Here we have the mass of magnesium, the relative atomic mass is 24, that of hydrogen is 1, that of sulfur is 1, that of sodium as 21 and that of oxygen as 16. Next, we try to look at what is the mole. And mole is basically a unit of measurement that is used in chemistry. So when we speak about mole, we need maybe to look at these examples that will help us to understand better the knowledge of what is a mole. A pair represents 2 items, while a dozen represents 2 items. A mole, in our case now, represents 6 or 2 exillion. This number is also referred to as the Avogadro's number, which is 6.02 times 10 to power 23. What is 1 mole? If you were to take 1 mole of bananas, like we have mentioned from here, then it means that you have 6 or 2 exillion bananas, which can be written in standard form as 6.02 times 10 to power 23 bananas. 1 mole of ions would mean that you have 6.02 times 10 to power 23 ions. 1 mole of molecules would mean that we have 6.02 times 10 to power 23 molecules. And finally, 1 mole of atoms would have or contains 6.02 times 10 to power 23 atoms, which is now 6 or 2 exillion atoms. Therefore, mole is just a unit of measurement. And every time you hear of a mole, what comes into your mind and should come into your mind now, it's 6 or 2 exillion. Exillion, which in standard form is this particular number, also known as the Avogadro's number. So the Avogadro's number in chemistry represents 1 mole, which is ideally 6.02 times 10 to power 23. We look at the molar mass. And what is the molar mass? Look at this particular example. We have 1 mole of atoms on a weighing balance, assuming that the mass is given in grams. And then we have molar mass on this other side. What this diagram simply illustrates is that 1 mole of atoms, the molar mass of any particular substance is the mass of 1 mole of that particular substance. To define molar mass, mass of 1 mole of a substance measured in grams. So that now, if I take, for example, 12, or let me use an example of 16 grams of oxygen. 16 grams of oxygen. That would be the molar mass of oxygen if the 16 grams contains 1 mole. What do I mean by that? I mean 6 or 2 exillion atoms of oxygen are contained in 16 grams. You see, ideally, these atoms are very big in size, just for illustration. But if there are 6 or 2 exillion of them, which ideally it's 1 mole, we said that 6 or 2 exillion simply represents 1 mole, they weigh 16 grams. Then that is the molar mass of oxygen. We already have calculated figures for this, and the molar masses of different atoms can be got comfortably from the periodic table. So basically, that is the relationship between the relative atomic mass, the mole, and the molar masses. Thank you for watching. Watch the next video so that you are able to understand now the relationship between mass in grams, the molar mass, and the number of moles.